Hello viewers, in today's session we are going to discuss another important problem from Dirac delta function, right? So here we are going to discuss this integral involving the Dirac delta function, and we have to evaluate this integral from 0 to 5, and we have e raised to sine square x and delta of cosine x, right? So here we see that we have a function as an argument in the Dirac delta function, right? So here we'll see how we can solve these type of integrals where we have a function inside the Dirac delta function, and we'll also see the property which can be used to solve these kind of integrals, right? So let us first quickly see the property which we are going to use, and let us quickly see the definition and some important properties of Dirac delta function which will be utilized while solving this integral, right? So let us start. So let us first call this integral as I, right? And here we can take this function as f of x. So let us take it as f of x e raised to sine square x, and let us take this function that is cosine of x as g of x. So here we have cos of x is equal to g of x, so that our integral it becomes 0 to 5. Here we have f of x and delta of g of x, right? Okay, so now here let us state the property which is going to be used here. Now see, when we have a function inside the Dirac delta function, say g of x, then delta of g of x is given by sigma. Here we have I, and then we have delta of x minus xi, and in the denominator we have the absolute value of g prime of x of I, right? And here this I denotes the total number of roots of this equation, that is the g of x is equal to 0, right? So here if we have say n roots of this equation g of x is equal to 0, then I varies from 1 to up to n, right? So let us first solve this equation g of x is equal to 0. So when we solve cos x is equal to 0, then the value of x is simply 2n plus 1 pi by 2, right? Because the cosine of x is equal to 0 whenever x is an odd multiple of pi by 2, right? And here n belongs to the set of integers, right? Now here when we take the value of n, or when we assign the value of n, then we have to keep the limits in our mind, right? Because here the limits vary from 0 to 5. So let us first take n is equal to 0. So when n is equal to 0, then one of the roots of this equation is given by say x1 is equal to 2 times 0 plus 1. Here we have pi by 2, then this is simply pi by 2, right? And if we take the approximate value of pi, then this is 3.14 divided by 2. So this is approximately 1.57, right? Now let us take n is equal to 1, and let us call the root as x2. Then we have 2 times 1. Here we take n is equal to 1. Then we have plus 1. Here we have pi by 2. So this is 2 plus 1, 3. That is 3 pi by 2, right? And again, if we take the approximate value of pi as 3.14 and multiply it with 3, and then we divide the result by 2, then we approximately get 4.71, right? So now let us take n is equal to 2, right? Although we cannot take here n is equal to 2, because see, if we take n is equal to 2, then we have the root x3 as 2 times 2 plus 1 pi by 2, and this is 4 plus 1 5, this is 5 pi by 2, and if we calculate the value of 5 pi by 2, then it is approximately 7.85, right? And this value 7.85, it does not fall within these two bounds, that is 0 and 5, right? So 7.85, it does not belongs to this interval 0 to 5, and these two values they belongs to the interval 0 to 5, right? So similarly we can show that the higher values of n, the roots doesn't belong to the interval 0 to 5, so we cannot take the values of n above n is equal to 1. And similar is the case with the negative values. If we take n is equal to minus 1, then the value of x is minus 2 plus 1 pi by 2, and this is minus pi by 2, right? And minus pi by 2 is minus 1.57, and minus 1.57, it does not belongs to this interval, that is 0 comma 5, right? So the important thing about this problem is that when we solve g of x is equal to 0, then the admissible roots of gx is equal to 0 are only these two roots, right? So here we have only two roots for n is equal to 0 and n is equal to 1. So our I in this case, it varies from 1 to 2, right? So now our property, it reads as delta of g of x is equal to sigma I is equal to 1 to 2, right? Because here we have only two roots, and here we have delta of x minus xi, and here we have the mod of g prime of xi, right? Now let us take first I is equal to 1. So we have delta of x minus x1 over mod of g prime of x1, and due to this summation sign, here we have the positive, and then we have delta of x minus x2, and here we have mod of g prime of x2, right? So we have x1 as pi by 2 and x2 as 3 pi by 2, right? So now the next step is to get the derivative of this function g of x is equal to cos x, right? So g prime of x is the derivative of cosine x, and this is minus sine x, right? Okay, so now let us find the mod of g prime of x1. So mod of g prime of x1 is given by a mod of minus sine x1, right? So this is the mod of minus sine x1. x1 is pi by 2. So this is mod of minus 1. So this is simply 1, right? And similarly, the absolute value of g prime of x2 is given by a mod of minus sine x2, right? And this is mod of minus sine 3 pi by 2, and here we have minus, then we have minus 1, because the sine 3 pi by 2 is minus 1, so this is plus 1, that is equal to 1, right? So these two values are both equal to 1, right? So now delta of g of x, it reduces to delta of x minus x1. x1 is pi by 2, and here we have delta of x minus 3 pi by 2, because x2 is 3 pi by 2. So now let us substitute this value of delta of g of x over here. So we have I is equal to 0 to pi f of x, which is e raised to sine square x, and here we have delta of x minus pi by 2 plus delta of x minus 3 pi by 2, right? And here we have dx. So now we can write this integral as a sum of two integrals. The first one is 0 to 5 f of x delta of x minus pi by 2 dx, and then we have 0 to 5 f of x delta of x minus 3 pi by 2, right? So now to evaluate these two integrals, we will make use of the definition of delta function, which says that if we have minus infinity to plus infinity, here we have f of x and delta of x minus a dx, then the value of this integral is equal to f of a. So the value of this integral is equal to the value of this function f of x at this point, that is x is equal to a, right? Because we know that the delta function is 0 everywhere except x is equal to a, right? So we have the spike or the peak at this point only, x is equal to a. So the delta function is infinite, or x is equal to a. The delta function is not equal to 0, and it is 0 except at x is equal to a, right? So the value of this integral is equal to the value of this function f of x at this point, that is pi by 2, due to this result. So we have here f of pi by 2, and we have already mentioned that this point pi by 2, which is approximately 1.57, it lies within these two limits, right? So we have f of pi by 2, and similar is the case with this integral. The value of this integral is equal to the value of this function at this point, that is 3 pi by 2. So here we have f of 3 pi by 2, right? So now f of pi by 2 can easily be evaluated at from this function by taking x is equal to pi by 2, and then by taking x is equal to 3 pi by 2. So we have e raised to sine square pi by 2, and then we have e raised to sine square 3 pi by 2, right? So this is e raised to 1 square, because sine pi by 2 is 1, and then we have e raised to minus 1 square, because sine 3 pi by 2 is minus 1. So we have simply e raised to 1 square is 1. So we have e raised to 1, and here minus 1 square is plus 1. So we have e plus e, that is equal to 2e, where e is the exponential number. So viewers, the value of this integral is equal to 2e, right? So 2 times the exponential number.